Cool. Hey, everybody. So today we are doing our project for kickoff, but I think almost everybody I've already talked to, like I've already given you all like some initial steps in starting your project, but I'll give you all some like very general guidelines on the things that I want to see with regards to this project. So I'm going to go project by project because I know most of you all actually are, I think, by the numbers. And I know it's like there have been some updates on the poll since there's been some updates since y'all did the poll results. I know most of you are actually going to work on the neural networks project. I think that's like the one with the most number of people. Also the simplest one to explain. So I'll talk about that in a little bit. So for each of these, I think we kind of have it evenly split between like rec systems, time series, and NLP. So we'll talk about that. And then with the image classification, I'll give you all some like, I guess, more direct guidelines. Okay. So here I've linked up the setting up your repo. You should already know how to do that. With this project, the data files are getting larger. So don't forget, especially for those of you doing the images project, or anyone that's doing like anything with big data sets, I think the NLP one is just small enough, so that one's still fine. But these large data files, as long as you have any data file that goes above 100 megabytes, you'll have issues pushing it up to GitHub. And if you do face those issues, let me know immediately. Or if you feel confident enough, you can follow these instructions down here. Over here at the very bottom of this. I put this here because a lot of people were facing that issue with this project. Basically, if you try to push a file that's too big, GitHub will reject the file. So you just have to undo the commit and then unstage that specific file and then add the file name into your Git ignore if you forgot. So this is a super, super common error that I run into especially during this project. So here's the code for that. Okay. So to start, business cases for each of these. I'll talk about them when we get to each of the projects more specifically, but this is the project that I'm going to nitpick a lot more on your business case, and I'm going to nitpick at it during your presentation. I know I don't have like the dates guidelines on this one. I wonder why. I wonder where it went. Okay, anyways, why is the changes made by anonymous? That's weird. The presentation is going to be in exactly 2 weeks from now. So again, as you all know, on the presentation day, you don't have to have your project completely completed, completely done, but at least have your business case set by then, because that's really the main thing I'm going to be grading. Is your business case sound? And then also, the main, like, all right, are you like, does your project presentation make sense? Are you showing at least some results? So on and so forth. Cool. So business case is the thing I'm going to nitpick at this time around. All right, so first, let's talk about the recommendation systems project. So I know during our recommendation system study group, I talked about content-based, I talked about collaborative filtering, I talked about a bunch of different ways that you can make recommendations. This project focuses on the collaborative filtering aspect. So you're only really going to be using the surprise library. So with the recommendation systems project, the provided data set is the movies data. So it's the movie lens data. It's actually the same data set or a larger version of the data set that I use as the like last example, or the first example in my study group notebook, if you remember that. So same data, you just have to train and test a bunch of different models. So with the business case for recommendation systems, it's interesting because recommendation systems, I think out of all of these topics, rec systems is the only one that is a product, right? I mean, that's how I like to think of it. It's like you're literally giving someone a recommendation of what movie they want to watch. And whereas for all of these other things, it's not a direct like consumer facing product. So that's a really interesting way that you can tackle the business case. Obviously, your business case is to generate recommendations for users, but maybe go one level deeper. Why specifically you're generating recommendations? Come up with a case. Like, are you a new streaming platform? How do you want to differentiate yourself from other existing similar recommendations? Do you want to focus on stuff like customer retention, learning about customers, so on and so forth? So come up with a business case for that. You can make something up. You can. I've had people like make up their own little streaming companies, stuff like that. That's really interesting to me. So EDA, something that's been pretty consistent over the last couple of projects, I think, is our EDA should be helpful for our modeling. So with our classification problem, we were doing very comparative EDA, as in like, what are the differences in the distributions of a feature between one class and another class, because those tie very well into, our feature importances for classification, into like what kinds of things that we want to focus on for classification analysis. Regression, same, we had all those assumptions that played into the modeling process, and those were the things that we were exploring in our EDA. So for recommendation systems where it's a little bit less straightforward, think about what are some of the problems that we face when it comes to recommendation system. And one of the most common things is actually popularity bias. I know for this given data set, the data set that they give you is anonymized. So you just get user ID, movie ID, and then whatever the rating is. Now, of course, you want to explore the distribution of your ratings. So first see that, all right, how in different scenarios, people rate things slightly differently, right? So maybe when you're rating a movie, if a movie is like, okay, you give it a 3. If a movie is super amazing, you give it a 5. If the movie sucks, you give it a 1. There's actually really interesting research that's going on about like people's different, what's the word? Like their different approaches to rating things. So now if you think about, I forget what it's called, but it's something like the Uber phenomenon, where if you're rating an Uber driver, as long as they're like okay and absolutely fine, most people just give them a 5. And as soon as like something goes wrong, it's immediately down to a 4. So like the centrality of ratings for like an Uber driver are completely different for like how ratings are distributed in something like this. So exploring things like that would be really interesting. Are there a lot more 4s and 5s in this data set versus like 1s and 2s, things like that. So distribution of ratings. How often are the users in this data set rating things? How often is each movie being rated? Stuff like that. And in terms of for non-technical presentation, really more interesting to an audience, things that you're curious about. What are the most popular movies in your data set? And this is where you can bring in the movies.csv. There's basically another CSV file provided in this data set where you have, the actual movies info. You can join it with the movies, with the ratings CSV. But yeah, I would say that I would deprioritize until you're done with the main modeling step. Cool. Okay, so in terms of modeling, I have linked over here all of the models that the Surprise library has. Within Surprise has their own train test split. It has its own cross-validation. It has its own grid search as well. So you can definitely do that, but follow a very similar process that you did for the last project. Pick 4 of these models to train and test. Make sure that SVD is one of them because SVD is the main one. But feel free to take, usually people use KNN basic or one of the KNN ones, and then they try SVD, SVD-PP, and then NMF, because these are all different kinds of matrix factorization models. Test baseline models for each of these, tune the values of the best ones, and that's your final model. So it's actually very straightforward as a project. This really not necessary for this project unless you're very, very confident. I would say like if you get all of this Surprise modeling done within like the next like few days, then I would try and tackle the LightFM, because LightFM has a very, very different syntax. But feel free, I have some examples and walkthroughs here. LightFM basically allows you to incorporate some content-based elements into your SVD model. So basically what will happen is you will run your SVD and it will basically re-weight your ratings based on how similar items are. So it gives a little bit more weight to the actual content of the movies. So that's really cool. With any of those models, whether it's Surprise, but even if you decide to incorporate LightFM, you have to interpret your metrics. So what is your RMSE? What is your MAE? What does that mean? RMSE for a star rating for movies, on a scale from 1 to 5, let's say you have an RMSE of 2. Is that good or bad in your opinion? Cool. And then as you know, we usually have to come up with some business recommendations in our presentation. Here's where you can perhaps do some post-modeling EDA. This is where you can start to explore some of your popularity bias. Are there some movies that are getting rated higher more than others? Are these specific subsets of movies? And then recommendations can be very similar to that of phase one, especially since we're dealing with movies. And then final product. This, I used to put this in future work, but I feel like because this step is actually in one of the labs, I do want to see it as well. So let's see, outlined in surprise lab. So try to do this, or really try to do this, because this is where it really becomes a product. Generate new ratings or recommendations to a new user. And then, if anything, at least start thinking about how you would make this a more robust recommendation system. Maybe talk about LightFM if you haven't already. Maybe talk about some of the additional information you would like to collect from users to make better recommendations for the future. At this point, any questions for the recommendation systems portion? I know, Mo, here, you're the only one here doing the rec systems project, but do you have any questions?
No, I think it's straightforward. I think, for my one-on-ones, if I have any questions, I'll bring it up.
Awesome, sounds good. All right, so next, let's talk about the time series project. I know, Sam, you said you're not going to do time series anymore. We talked about this. Nelson, you mentioned that you're not going to be using the provided data set. So let me talk about a provided data set, because I know someone is doing that, and then I'll move on to talk about if you're doing a general time series. So for the provided data set, as I've mentioned, is basically a bunch of Zillow zip codes, and the business case is you're trying to build models for a bunch of zip codes, make predictions on one. The way that I recommend most students to go about this is just shortlist your zip codes, and you don't even have to do this. You don't have to do this algorithmically. You can pretty much like filter maybe like the city that you are in, the city that is nearest to you, or cities that you're familiar with. Maybe like tier 1, tier 2, tier 3 cities, whatever it is. I usually recommend that students just shortlist this so that you're not processing like hundreds and hundreds of time series models. So do that, and then do an in-depth analysis on one zip code, replicate it quickly on the rest, and then you can make a recommendation from there. So here in terms of EDA, and business case, I feel like is pretty self-explanatory for the provided data set. You're just trying to do zip code picking for investment. So for EDA, you're analyzing time series data for multiple zip codes. How can you make your EDA most efficient so that you're not doing an EDA for each zip code? Maybe you form groups of zip codes, make sure that there's as little code redundancy as possible. So this is kind of like a note that I made for people who have decided not to select some zip codes out of like the 100 provided. If you are, let's say maybe you choose like 6 or 7 zip codes to go off, and that I think is a good number to go off of. If you have 6 or 7 zip codes that you go off of, do an in-depth analysis on just one, and then maybe write some functions to spit out analysis for other zip codes. And you don't have to show all of it in your notebook because it's going to be very repetitive anyways. Cool. The usual check for stationarity and seasonality, do your HCF, your PACF, seasonal decomposition if you'd like. Exogenous data, this is very, very optional for this project, especially if you're doing the provided data set. So you would just want to do the regular EDA on your exogenous data as well. Okay, so when it comes to modeling, and this does apply to whether you're doing the provided data set or not, think about how you're going to do your chain test split. Now, I only mentioned this because there is a potential pitfall if something happens during the time where you choose your chain test split. So for example, if you decided to do some sort of analysis on like the last 10 years and your chain test that you want to do like a 90-10 split, the last year is going to be COVID, and who knows, probably whatever happens, things are going to look quite different in this last 1 year versus the 9 years prior. So be very cognizant of that. I think a lot of the traditional time series models are going to underperform because so many exogenous features have caused time series, the time series to perform differently over the last year versus your chain set. So because of that, and actually this is done especially I know in the finance industry, it is done for benchmarking. Some people actually try to ignore the COVID effect. I think it's like February to like August. I only know this because I was like contracted to work for a finance person for a while. But yeah, February to August, they actually choose to ignore those dates. Like those dates never happen. They just like fill it in, regress, or literally just drop all of those dates. So that's something you can think about doing, especially if you know your chain test split really falls somewhere where the before and after that split point looks very different. So careful about that. As with all modeling, pick a baseline model. Maybe it is a very, very simple AR or MA model, perhaps even a straight line. Picking the average to be your baseline is actually not as bad as it sounds for time series. So with that, definitely start with your traditional time series models. My suggestion for how you structure this modeling, start with your AR and MA values that you got from your ACF and PACF graphs. Start there, get some results, make some forecasts and predictions, and then throw it into auto ARIMA. You can pretty much tell it what a starting and ending PDQ values you want it to run through, and it'll basically do like a grid search of that, and it'll spit out AIC values, so you can pick your best fitting model from there. I've also linked an auto ARIMA walkthrough. One pitfall I see students just immediately start with auto ARIMA. Don't start with auto ARIMA because you do want to show that you know how to interpret ACF, PACF graphs to inform your modeling. Even if your best model happens to be ones that are different from your ACF and PACF, I mean, that's really part of the modeling process. You should be documenting that anyways. Cool. So for the provided data set, there are many ways to determine the top zip codes. It's important to document your thought processes and back up your modeling decisions. So let's say you have 6 shortlisted zip codes. You don't necessarily want to always pick the one that is predicted to have the highest ROI. Maybe use ROI, but also look at the volatility of, or like the overall error that you have. So if you have like a high RMSE along with a high ROI, let's say you calculated the ROI for the next like 5 years, is that your best investment? Maybe good for a risky investor, but maybe someone who's more risk averse, you might want to pick something different. So there are many ways that you can go about determining this, very business context dependent, and you can use your best judgment as well. So after you're done with the traditional time series modeling, throw it into Facebook Profit. I think that's an easy next step because the Facebook Profit code is provided to you in one of the appendix labs anyways. And if you really, really want, you can also implement an RNN, although that is like a very, very big stretch goal. So you can do that. If you are not doing the provided data set, I would say use the same modeling structure, like start with some baseline ARIMA models or baseline AR or MA models, do some auto ARIMA to tune Facebook Profit. You can tune Facebook Profit as well. And then same, level up if you can. And the main thing with time series model is to really think about how you're evaluating your models differently from how you would evaluate like a regression or a classification model. Sure, there's RMSE, but you know, you can also eyeball and look at the forecast line. If you have, you know, big changes in your test set that aren't really taken into account with your chain set, can you be a little bit more forgiving with RMSE? That's really something that you can take into account as well. All right, and actually, yeah, even for the non-provided data set, the EDA is pretty similar. I actually now come to think of it, you just don't have to think about, you don't really have to think about the process of repeating this for other zip codes. Cool. So business recommendations for the provided data set, very, very similar, which zip codes you're investing in and why. And then also if you're including exogenous variables, something that you can think about is coefficient analysis. So if you're doing exogenous variables with ARIMA modeling, don't forget that you get that little table output exactly this. I mean, it's from stats models as well. So you interpret the coefficients very similar to how you interpret your linear regression coefficients. So if you choose to include exogenous variables, you can interpret your coefficients from there as well. Cool. Any questions about the time series project at this point? Okay, so next, NLP. So NLP Modeling wise is actually, it can be exactly the same modeling process that we did for the last project. I'm going to talk about some different ways that you can differentiate this project from the last one, obviously. So business case, what are you using the NLP for? What is your final product? So the provided data set is basically a bunch of tweets, and it's from 2012. So feel free to update your data set if you want. There are a lot of good NLP data sets, or not good, but there are a lot of NLP data sets available on Kaggle. Just let me know if you want to change it. Yeah, the data is a bunch of tweets about different products that were being released or showcased at South by Southwest in 2012. And they're all positive, negative, or neutral. Advice that I'm giving to you all, if you ever have like a positive, negative, neutral, where it's kind of like a spectrum, feel free to drop the middle class because it really is there to kind of confuse the model, because there's like a middle ground between the two extreme classes. So you can definitely go from a ternary to a binary problem and then reintroduce a neutral class later. So for here, it's really just sentiment analysis. Can you figure out what people are happy about, unhappy about with these like tech products that they're showing? I think like things that were coming out during this time, Google Circles, the social media platform, was out. I think one of the first iPads came out around those years, something like that. So those are the products that people are talking about. So it really can be used to, you know, understand consumers, how consumers feel about these products, figure out how they can better their products for next year, stuff like that. So all in all, this is still a classification project. So again, make sure that your EDA is comparative, aiding your modeling. You can do a lot of the very, very similar EDA that we were doing in the last project. Of course, now we have words. So make sure that you're analyzing your text kind of side by side with the different classes. Word clouds, very, very common in NLP projects. Save them for the present. I mean, you can have them for the presentation, but I still want to see a quantitative equivalent in your notebook. So what if you don't have like numerical bar graphs in your presentation, that's absolutely fine. But if you choose to have word clouds, I do want to see a quantitative equivalent in your technical notebook. As a level up, you can do clustering or LDA for your EDA. Again, this should be comparative. So I usually recommend people, if you have the extra time, throw each class's group of words into an LDA model, just so you can see you know, what are the main topics that are being discussed within each class. Okay, so two ways to do the modeling. One, you can compare pre-processing methods. One, you can compare models. So this is pretty much exactly the same process that we had for the last project. Just pick a pre-processing method. Maybe you do TF-IDF on all of your text data, and you can just run all that data through all of the models, grid search the top one to make your conclusions. That's it. So this process is exactly the same as the last project. You're just vectorizing text instead of, you know, your numerical data from last time. So you can totally do that. I have no qualms against it, but I really do think to differentiate this project from the last, do an exploration of pre-processing techniques. So in this case, we have had multiple pre-processing techniques. The main ones that we talked about: count vectorizer, TF-IDF, word embeddings, which is still, I know it's an appendix material, but it would be really worthwhile to check out as a comparison between, you know, the bag of words methods and the word embeddings methods, and basically see how it affects the performance of your model. So with this approach, you can do 1 to 2 models, and that's it. So what you're mainly exploring the differences between are the different text pre-processing methods. Now, when you do grid search, you can also grid search parameters for your pre-processing methods. So if you remember, actually, let me pull it up real quick since we are here. And I think this is useful for all of you to know as well. So phase 3, where did I talk about it? Here. Okay, hopefully it loads up quick. I think this is where I talked about grid search, right? Okay, cool. So here, let's say you have your TF-IDF vectorizer and you want to compare, okay, my max features. As I mentioned before, within your TF-IDF vectorizer, one argument that you should definitely adjust is TF-IDF is the max features, and basically how many of the top words you want to keep, because words that have appeared only like once or twice will only be there to like add noise and extra dimensionality to your data that you don't need. So max features here, let's say you want to try like 1,000 to 2,000, 3,000. I mean, depends on how many there are before capping it. Let's say you want to adjust the max features. You can actually throw that into your grid search if you have a pipeline. So definitely try and set up a pipeline. Here you can see that these are all model parameters, but if I wanted to do like a TF-IDF, I would just do TF-IDF, instantiate TF-IDF there. And then here as part of the grid, just add more keys. So you can be like TF-IDF underscore underscore max features, 1,000, 2,000, 3,000, and you can tune your preprocessor along with your model. So with that, you are running fewer models. So because of that, you can choose the models that will run fast. Like for example, I usually recommend some tree-based model just so you can get feature importances. So random forest, maybe a boosting model, pick one of those, and then maybe naive Bayes, just because that one is fast and usually pretty accurate on text data. And then do your post-modeling EDA. This is the main reason why I suggest to use a tree model. Based on the top performing or the most important words for a classification model, it's not usually that obvious which way it makes it lean. Like, for example, some words like bad or sucks or awful, you're like, okay, this is obviously negative, but sometimes it's less obvious. Maybe a word like iPad comes up as most important feature. You want to know whether it's important because it indicates positive or negative. So you should go back into your EDA, see relatively where does the word iPad come out more? Is it more on positive, more on negative? And you can actually make some meaningful analyses or recommendations from that. Cool. So actually, yeah, this is exactly what I was just saying. What words led to classifying your sentiment as positive or negative? How can companies adapt with this model to better serve customers? Cool. I know no one here is doing the phase 4 project for on NLP, but I know some of you are interested in incorporating NLP in your capstones, perhaps. Any questions at this point? Cool, cool. All right. So finally, image classification project. So this one, honestly, is one of the more straightforward projects. In classification of these images, the business case lies in the task itself. You just want to, detect abnormalities in chest X-rays. The data set provided is pneumonia. If you have a different data set, you can adapt it to whatever it is that you're classifying. So EDA is easier / harder. Easier in that there is less EDA to do, harder in that there is less EDA to do. So do as much of a summary as possible in this section. Output a couple images from each class as some examples, and then just look at the class balance. That's pretty much it. Maybe you want to make some notes about how many images you have of each. Maybe just put literally in like a markdown cell, what are the dimensions of your images, stuff like that. So, okay, in terms of modeling, start with a baseline model. It's kind of up to you to decide what this will be. I kind of have told some of you already that start with a non-CNN. So just start with an MLP dense network. Maybe it can be a gigantic network, dense network, but usually I say as a baseline, flatten out your image into a long array and run it through a classification model that way. For this project, you can experiment with different structures. That's really what you're doing in this project, experimenting with different kinds of neural networks. And I highly, highly recommend including convolutional layers, even though, because this is in the appendix, it is technically not required. I would love to see if you're doing an image classification project that you use convolutional layers, because I feel like there's no point in doing image classification if you're not doing convolutional layers. But again, if you don't do it, I cannot stop you from not doing it. So there. Things that you can include. Some of these things are really not difficult. Using pre-trained networks is not hard to do. So I definitely think that would be a good, easy level up to try. These I'll talk about in a little bit. Include some tuning in one of your models. Whether you use grid search or Talos, you should introduce some parameter tuning. In total, I'd like to see 4 neural networks and 4 meaningfully different neural networks. So some of these other things that we haven't really talked about, visualizing intermediate layers. I didn't talk about this because there is a lab that talks about that in the appendix. So it's basically at any one point in time, you can actually generate a heat map to see which are the neurons that are firing. So really, that's actually really cool to look at. There's a lab for it. Another thing that you can think about is data augmentation. Data augmentation is a really interesting thing. We didn't really have time to talk about it this week or last week, but really quickly, data augmentation just serves to help your neural network understand your data better by taking your image and doing different slight augmentation to it, not augmentation, but making slight changes to your images to basically grow your data set. So let's say you have a bunch of pictures of dogs and you want your neural network to get better at recognizing dogs. Maybe they'll take your image, rotate it slightly, because not all the time the dog is going to be like standing straight. So maybe they'll rotate the image slightly and count that as another image. They'll flip the image like 180 degrees, something like that. Perhaps they will invert it, like mirror the image, so on and so forth. And you can actually play, there's a lot of different kinds of data augmentation you do. You can do like stretching, like lengthways, up and down, anything like that. So data augmentation, one, it can help with class imbalance, but two, it can also help your neural network understand more variations of your data. Cool. When you're making your incremental changes to your, not incremental, but as you're making your iterative changes to your model, document why you're making this change and what your hypotheses are. Will accuracy improve or not? So a lot of those answers, like why would you want to include pre-trained networks? Because the networks have already been trained to recognize very general elements of photos, literally document it that way. And what your hypotheses are. Of course, most of these things you would expect hopefully your accuracy to improve, or maybe you can talk about train time or the different how your, what do you call those, your accuracy and loss curves will change. Make some hypotheses up. That's really how you learn from that. So yeah, in terms of recommendations for this project, the recommendations for this project are usually more qualitative in general, because you just can't extract meaningful information from the model. Again, black box, millions of parameters that you're tuning. Possibly you can make recommendations on model architecture. You can totally go and take a look at the one that I linked yesterday. So let's see, yesterday, is it this one? Nope. Here we go. So yesterday, I linked this article that goes through, this is not yesterday, I'm talking about last week's one. Is it here? Okay, so last week, when I introduced convolutional neural networks for the first time, I linked an article at the bottom that actually has a very good iterative approach to developing a CNN from scratch. And they walk through very many different iterations, and they include a lot of different things, even things that we haven't talked about. So I think this is a really good one to follow and read, and just to learn why they would decide to add different things like kernel initializers, batch normalization, stuff like that. This is a really good, it seems like a very long article, but a lot of it is just code. I think is a really concise way to talk about like incremental changes to your model. Cool. So finally, there is a library. It's actually very similar to the visualizing intermediate layers, that you can overlay a heat map to find out the most important pixels per image. I forget what it's called and where it is, but if you do a Google, you'll be able to find it. So that might be a really cool one that you can do, but it is done like an image per image basis. Cool. In terms of the models, I've told a couple people this. So like my suggestion for models would be first start with the baseline multi-layer perceptron. So basically just dense layers. Then start with a baseline CNN. Then maybe a CNN with pre-trained network. And then maybe a CNN tuned with Talos or grid search. So with that, you have 4 models. That's my suggestion for how to go about this project. But of course, you can do whatever you like. All right, any questions for this image classification project? Sweet, yeah, I thought so too. It's pretty straightforward. Okay, so don't forget that the presentation is 2 weeks from today. And then, yeah, as I've mentioned before, I have a lot of free time in this 2 weeks, so feel free to throw extra one-on-ones on my calendar. Usually for some reason, well, I think I know why that is, but Thursday and Fridays, my calendars are a lot more full. So if you have any like questions Monday through Wednesday, or just want to chat about something, feel free to let me know. Throw it on my calendar. I have a lot of free time. So cool. Any questions about anything I've said about this phase 4 project at this moment? Amir?
I have a question, but it's about the project and it's not related to what was discussed today. So if you could
Okay.
just hang that, yeah.
Yeah.
Breaking down.
Absolutely. Anyone else have any questions? All right, let me stop this recording then.